Alright, and here's the third question that we will be attempting. So this question says, prove by mathematical induction that bracket 1 minus a to the power of n is greater than 1 minus n times a, for n being a positive integer, but being greater than or equal to 2, and a lies in between 0 and 1. So this type of question is known as inequality induction questions, and what they are expecting you to do is to find three expressions, a, b, and c, such that if a is greater than b and b is greater than c, you can conclude that a is greater than c. So by using this principle, we'll try to attempt this question. So let's start with step 1. Let P n conjecture that 1 minus a to the power of n is greater than 1 minus n times a, for n being a positive integer, n being greater than or equal to 2, and a lies in between 0 and 1. Alright, now let's choose a number to test this with. Now, because n is a part of positive integer, but n has to be greater than or equal to 2. So I'm going to check with n equals 2. So check with n equals 2. So that would be Pn. So let's start with the left-hand side. So the left-hand side is 1 minus a to the power of 2. And that is equal as 1 minus 2a plus a squared. And let's look at the right-hand side. Right-hand side would simply be 1 minus 2a, right? Now here, you can see that this part of the expression and this part of the expression is the same. But we know that a squared is always positive based on this condition. So left-hand side is, yes, indeed, greater than right-hand side, and P2, yeah, this should be P2, sorry, P2, it's true. Okay, now, since we tested that this is true, let's go on with assuming that PK is true, such that 1 minus a to the power of k is greater than 1 minus k times a, for k being a positive integer, k is greater than or equal to 2, and a lies in between 0 and 1 again. Alright, let's go on with the induction step and check with k plus 1, so need to show that, so k plus 1, which is the same as 1 minus a to the power of k plus 1 is greater than 1 minus k plus 1 times a. Okay, so as again, start with the left-hand side and try to work things out. So left-hand side, 1 minus a to the power of k plus 1. You can rewrite this as 1 minus a times 1 minus a to the power of k, right? And then what's our next step? Again, use the step from step 3. So we know that, going back here, pk is same as shown as this, right? So, and you see how this part is repeated here? What this means is that this entire expression should also be greater than this times 1 minus a, because this part is the same. Times 1 minus ka. You see, right? And also because this is always positive based on this condition. So you know that this expression also holds true. And if we try to simplify this expression, so greater than 1 minus a plus, 1 minus a, sorry, 1 minus a minus ka plus ka squared. And we can simplify this further as 1 minus k plus 1 to the power a plus ka a squared, right? Now let's look at the right-hand side. So we know that the right-hand side is immediately 1 minus k plus 1 times a. Now, do you see how this expression is the same as this expression? But then the right-hand side is less than this expression because is less than this middle expression because ka squared is always positive based on this condition. So here we've done it. If we let left-hand side become a, and let this middle term become b, and let this right-hand side term become c, you know that the left-hand side term a is greater than the term b here, based on this. But we know that the expression b is greater than the expression c. You see, a greater than b, and b greater than c. And so, a greater than c, left-hand side is indeed greater than the right-hand side. So, p, k plus 1 is true. And then now we've successfully proven this. So again, write your conclusion. P2 is true when pk is assumed true. Pk plus 1 is true. Hence, by mathematical induction, Pn is true for n being a part of a positive integer and greater than or equal to 2, and a lies in between, and 1. Okay, so this can seem like a confusing question, but you just have to remember 3 things. Firstly, we proved that the left-hand side's expression is greater than this middle expression by using the term of pk. And then, by observation, we concluded that this middle term is greater than the right-hand side term. And so we came up to this conclusion. And that's how we did this question. And here's our final question, which we'll be attempting today. So this type of question is known as the nth derivative induction, where you have to find the nth derivative of a function by using mathematical induction. It is considered a bit more challenging than other induction problems because it requires you to use the knowledge of your calculus and the derivative functions, but it's still doable. So let's do this question. So consider the two variables, x and t, linked by a relation t equals 2x times e to the power of 2x. Show that the nth derivative of this is equal to this expression. Okay, let's start. Step 1. Let Pn conjecture that if t equals to x e to x, then dnt dx to the power of n equals to 2nx plus n 2n minus 1 e to the power of 2x. Okay, step 2. Check with n equals to 1. If a question does not give you a specific condition to use, just assume you can use n equals 1. So that would be P1. Let's look at the left-hand side first. So if we differentiate the left-hand side, that would be dt over dx, which is the same as if we use the product rule here, that would give us x times 2e 2x, the derivative of e to the power of 2x, plus e to the power of 2x times 1, which is the derivative of x. So that would give us, if we take off the common factor, e to the power of 2x multiplied by 2x plus 1. Now let's look at the right-hand side. The right-hand side in this case would just be that 2 to the power of 1 x plus times 1, 2 to the power of 1 minus 1, e to the power of 2x. And then this is just equal to 1, 1, So that would become 2x plus 1 times e to the power of 2x. Now, because they are the same, we know that P1 is true as left-hand side equals to right-hand side. Okay. Now, let's go to step 3. Now here, we assume that pk is true such that d to the power k of t over dxk is equal to 2 to the power of k x plus k times 2k minus 1 bracket e to the power of 2x. And then need to show that pk plus 1 is true, which means that we have to show that dk plus 1 t over dxk plus 1 equals 2k plus 1 x plus k plus 1 e to the power of k e to the power of 2x. Alright, so again, start with the left-hand side. If we start with the left-hand side, it's firstly dk plus 1 t over dxk plus 1. Now, this is the same as d dx of dk t over dx to the power of k, because this is just the next derivative of the previous derivative function, which is given here. Now, using pk as again here, this one, so if we sub it in, it literally becomes the derivative of the dx of pk, which is t to the power of kx plus k to the power of 2 k minus 1 times e2x. Now we will differentiate this again using the chain rule, which would give us e to the power of 2x plus the times the derivative of the other function, which would just be 2k as f terms are cancelled, plus the other plus this function plus k times 2 to the power of k minus 1 times the derivative of the other function, which would just be e2x. And then we can take out a common factor of e to the power of 2x. So that would be e to the power of 2x. Then we will have 2k plus bracket 2kx plus k times 2 to the power of k minus 1 times 2. And then we can expand the bracket by multiplying the 2 into this bracket, which would give us 2 to the power of k plus 2k plus 1 x plus k times 2 to the power of k, right? And then, again, we can simplify this by taking out the common factor of k plus 1 in here. So this expression would just simplify into e to the power of 2x bracket 2k plus 1 x, which is this, and take out the 2k, it becomes k plus 1 times 2 to the power of k. And now, you see that the left-hand side expression is the same as the right-hand side expression. And so, based on this, left-hand side equals right-hand side. Hence, p k plus 1 is true. And then, to step 5, conclusion. P1 is true when pk is assumed true, pk plus 1 is also true. Hence, by mathematical induction, Pn is true. And so, we have looked at 4 different types of questions on induction in this video. If you enjoyed the video, please like and subscribe to our channel, and we hope you visit our channel once again to learn more about math. Thank you.